I'm Anil Kumar, and here is the test problem involving exponential and logarithms. Solve e to the power of x plus e to the power of minus x divided by e to the power of x minus e to the power of minus x equals to y in terms of y, right? So that is your question. You can pause the video and answer the question. Here is my suggestion. Now to solve such a question, let us first write it once again. E to the power of x plus e to the power of minus x means 1 over e to the power of x, okay? Now here also e to the power of x minus 1 over e to the power of x. Now we can take e to the power of x as the common denominator, right? So in that case, what do we get? We get e to the power of x times all this, right? So when you take e to the power of x common denominator, it gets multiplied with this. So what we get here is, let me show you, e to the power of 2x plus 1 divided by e to the power of x. So I've taken e to the power of x as a common denominator in the numerator. Same case for the denominator. E to the power of x times e to the power of x will give me e to the power of 2x minus 1 divided by e to the power of x. Now we can simplify this. E to the power of x and e to the power of x cancel out, correct? So they cancel out, and we are left with e to the power of 2x plus 1 divided by e to the power of 2x minus 1. So this is our left side, right? So that is how we can solve the left side. And now let us write down this left side equals to the y, and then we'll solve for the equation itself, okay? So what do we get here is e to the power of 2x plus 1 divided by e to the power of 2x minus 1 is equals to y. Do you see this y, right? Now let's solve the equation. So we just simplified this left side first, and then we are now simplifying the equation. We need to find answer in terms of y. Let us cross multiply. So if I cross multiply, I get e to the power of 2x plus 1 equals to y times e to the power of 2x minus 1. Now I need to find what x is, so I'll bring e's together. So I have e to the power of 2x minus y times e to the power of 2x equals to, when I multiply this with minus 1, I get minus y, and this minus 1 I'm taking to the right side, so I get minus 1 there also, right? Now here I can take e to the power of 2x common, so I get e to the power of 2x common, 1 minus y equals to minus y minus 1, and then we can actually solve for e to the power of 2x. So we get e to the power of 2x equals to minus y minus 1 divided by 1 minus y, correct? So we have at least isolated e, right, to one side. Now to solve further, we need to use logarithms, correct? Anyway, since there are a lot of negatives here, we can take negative common. So I'll rewrite this equation as e to the power of 2x equals to, if I take negative common in both, I get y plus 1 in the numerator, and here if I factor out negative, I get y minus 1 in the denominator, right? So that is, you can say, multiplying by negative in numerator and by negative in denominator will make these positive, y positive, and we'll just change the sign, correct? So we get that as our answer. E to the power of 2x is equals to y plus 1 divided by y minus 1. Okay. Now in this case, what should we do further? Now we have to take log. So log we should take ln. Now you know ln e to the power of x is equals to x, right? So that is why we will take ln. So if I take log to the base e, ln is log to the base e, then we get ln e to the power of 2x equals to ln y plus 1 over y minus 1, correct? Now that gives you 2x equals to ln y plus 1 over y minus 1, or x is equals to half of ln y plus 1 over y minus 1. Do you see that? So that is the final answer in terms of y, correct? So we now know x is equals to this. Now of course ln this should be positive, correct? So this means that y should be greater than 1, only then it is positive. So in this case we have a restriction, and that is y is greater than 1, and then we have a solution in this particular case, correct? So if y is greater than 1, then the denominator is positive, and right, so that is one thing. And but if y is negative, and we have y negative here also, so well, to find this domain we should actually find the intervals. So let me do this part again. Okay, so what we will do is, to find the interval of the domain, which I'm kind of extending this question, we have 0 in the numerator at -1, right? -1, and undefined for 1, correct? Now if I take a test point between, let us say take a test point between -infinity to -1, let it be -2, between them as 0 and then here as 2. So if I substitute -2 here, then what do I get? Let us check y plus 1 and y minus 1. So if I substitute -2 here, I'll get negative. For 0 I'll get positive. For 2 I'll get positive. In this particular case this will be negative, and if I put 0 it will be negative, and if I put 2 it will be positive. So when do we get positive? We get positive when y greater than 0, and also when y is less than -1. So the domain is y greater than 1 or y less than -1, correct? So that is the domain for this particular function, correct? So finally we can write down our answer, and our answer is that x is equals to half of ln y plus 1 over y minus 1, where y belongs to real numbers and y is less than -1 and y is greater than 1, right? Or sometimes you can say absolute y is greater than 1, right? So you could also write here absolute value of y is greater than 1. That's another way of writing the same domain. Okay, so I hope with this you understand how to write exponential function in terms of y, right? So whenever you're working with e as the base, you take ln, since ln and e are reciprocal of one another. Okay, I hope that helps. Thank you.